This video is about factoring perfect trinomial. A very quick explanation about a perfect trinomial. So you should have learned about the square of a binomial or multiplying a binomial to itself because it will lead you to understand more about perfect trinomial. Now the question is, why are we factoring perfect trinomial, or why are we factoring trinomial? First one is you are being trained on how to solve an equation. Okay, so for example, solving equations in a quadratic equations. Many quadratic equations can be solved by factoring. Okay, the next thing is you have the knowledge about simplifying expressions, like reducing fractions. Factoring can help simplify rational expressions by canceling common factors, just like that. Okay? The next thing is that factoring helped us find the x-intercepts in terms of graphing of functions. And of course, in the concepts of calculus and pre-calculus, factoring is really essential. Okay, why? Because in calculus, factoring is used to find derivatives and integrals. In pre-calculus, factoring would help to understand about rational functions, polynomial functions, and conic sections. Now let's go to the next slide. So here is a note. Factoring a perfect square trinomial yields the square of a binomial. So this means that a perfect square trinomial is a trinomial that can be factored into the square of a binomial. So remember that. And it can be written in the form of, okay, so see this one. The perfect square trinomial with a PST can be written as a plus b squared. The quantity of a plus b squared, that is equal to a squared plus 2ab plus b squared. Or the quantity of a minus b squared is equal to a squared minus 2ab plus b squared. So let me explain to you this formula. In the first formula, it means to say that the a plus b squared, do you see this one? Okay, this formula, this part of the formula, this means that we're squaring a binomial. Okay, that is a plus b, because the square, we're squaring binomial. And you see this a squared, what do you mean by this a squared? This means that the square, this means about the square of the first term that represent the a. And then you see that 2ab, the 2ab is the twice the product of the first and the second term. Okay, so the a and b, again, the 2ab is twice the product of the first and second term. All right, so the last here is the b squared. So this is the square of the second term. Okay, that's why it's b squared. All right, so let's have the second formula that is in, what's that, negative or subtraction. All right, that is same true with the first formula. Now, let us explain also the formula 2. But of course, it is same with formula number 1. So it's just with a different, what do you call that, sign. You get. So let's have this example. How are you going to determine whether this are perfect squared trinomial? So let's have letter A. Is this a perfect trinomial? Okay. It is. This is a perfect trinomial. How about letter B? Is this a perfect trinomial? It is not. Now we're going to talk about this. X squared minus 10x plus 25, x raised to 8 plus 6x4 plus 36. Okay, remember that when factoring a perfect square trinomial, you are then expected to arrive at a square of a binomial or binomial multiplied to itself. Okay. So we're going to explain why letter A is an example of a perfect square trinomials. Okay, so x squared minus 10x plus 25. So in the first term we have x and x, that is the square root of x. The square root of x squared is x, so we're going to double that. So x times x to get the first term x squared. Same through with the last term. We have 25. We have negative 5, negative 5. We're going to multiply that. It would give us positive 25. And of course, the square root of 25 is 5, but we use negative 5. That is to meet the negative 10x in the middle term. All right. So note that the first and the last terms are perfect squares. And the middle term is twice the product of the values. Okay, that's very clear. So that means that we are going to multiply x times negative 5, that is negative 5x, and x times negative 5, that is negative 5x. It would give us negative 10x. Okay, so same to with this, so we're going to put there an x. So we found the middle term, which is the negative 10x. So thus x squared minus 10x plus 25 is equal to this what do you call this one, the binomial, the square of the binomial, which is x minus 5. Okay, again, the given trinomial x squared minus 10x plus 25 is an example of a perfect square trinomial because it meets the criteria for both the first and the last terms being perfect squares and the middle term twice the product of their square roots. We can factor definitely into a square binomial x minus 5 raised to 2. Okay. And letter B, we are going to explain why it's not a perfect square trinomial. So 8 raised to, x raised to 8 plus 6x raised to 4 plus 36. So we're going to see here the roots or the square root of x raised to 8 is x4. So I'm going to double that. So times x, that's 4. So we're going to put it here 4 because if we are multiplying in the variables, we're going to add the exponent. If we're going to add exponent 4 plus 4, this is 8. And then of course the last term we have 36, and then the roots are, or the square root of 36 is 6. We have 6, so we're going to put another 6 there. So 6 times 6, that is 36. Those are the points or the roots. And we are going to examine if they are an example. If the first term is a perfect square, yes, it is a perfect square, right? Okay, how about 36? Definitely it is a perfect square. Now let us check the middle term. The middle term is positive 6x raised to 4. So here is the answer. If we're going to multiply 2 times x raised to 4 times 6, that is equal to 12x raised to 4. So it does not meet the middle term. So definitely, because of the middle term, to meet the rule, which is the twice the product of the square roots, which is the 2 times x raised to 4 times 6, that is 12x 4. So the conclusion here is that even though the first term is a perfect square and the last term is the perfect square, the middle term doesn't satisfy the condition for a perfect square trinomial. So it is not a perfect trinomial. Okay, so even if you're going to put the square binomials, the x raised to 4 minus 6, and it doesn't give the same expression or the same equation. That is x raised to 8 plus 6 is 4 plus 36. Okay? Now, you should remember that perfect square trinomials are a special type of quadratic expressions that play a significant role in various mathematical contexts, particularly in algebra. Okay, so thank you for watching and catch up with me in my next video.